Hey, sunshines. So we're going to do a triangle congruence proof. This is what I like to call an hourglass triangle, where you have two intersecting segments, and then the additional segments to close them out and form two triangles. So it looks kind of like a crooked hourglass. So we need to look at, to start with, we always want to start with our given information. I'm given that segment SM is parallel to segment LE. This symbol here means parallel to. So the first thing I want to do is actually mark up my diagram and say, I know that these are parallel, so I'm going to put the little arrows to show me that these are parallel segments. So these little arrows mean parallel to each other. Two arrows means those two segments are parallel to each other. If I had another pair of segments that was parallel, I'd put a different number of arrows. I could put one arrow, I could put three arrows, whatever makes me happy. Now, parallel lines give me angle pairs. So if I have a pair of parallel lines, I probably am going to need a pair of angles. I'm probably going to find that a pair of angles is congruent, and I'm going to need to use that. And of course, we're doing triangle congruence proofs, so I want to find pairs of angles that are congruent and pairs of sides that are congruent. So before I can identify my angle pairs and use them, I need to state that the segments are parallel because they are given. I need to actually put that statement into my proof. Now I can look at angle pairs. So for this, I've got a segment connecting that's in the interior. I don't have anything in the exterior, so I'm not going to be dealing with corresponding or alternate alternate exterior. I'm looking for alternate interior angles. So I actually have my choice. I've got two segments connecting, so I've got two pairs. I've got this pair here, and I have this pair here. So that gives me two pairs of angles that I already know are congruent. I also know that I have a pair of vertical angles here. So I can choose any two pairs of angles. I don't need all three because none of my shortcuts have more than one A in them, but I've got two different methods that I can do using two pairs of angles. And it's actually going to be my choice which I pick, because I already put this one in here. I could do the vertical angles, or I could just choose to pick both of the alternate interior and ignore the vertical angles. So the proper reason is alternate interior angles of parallel lines are congruent, but we're allowed to just kind of shortcut it when we know we're talking about parallel lines. I accept just saying alternate interior angles for the sake of space and everyone's sanity. I don't make you write it all the way out. So I'm going to pick angle M and angle L as my second pair of angles. Again, I can do a different proof, and I will show you that example in a little while. I could do an entirely different proof where I use the vertical angles and instead of angle M and angle L. But I only need two pairs of angles, so I'm not going to worry about the vertical angles right now. I'm just going to focus on these two, and then I need a pair of sides. You always need to have a pair of sides that's congruent to give you congruent triangles, because otherwise you don't know if the triangles are the same size. If all you have is angle pairs, that doesn't give you scale. You could have one triangle that's 1,000 times bigger than the other triangle. So I used this, but now I want to look at this one. I know that point I is the midpoint of segment ML. So I'm going to put that into my statements, and then I'm going to use that information. I is the midpoint of segment ML. That means it's in the middle. That means it's cutting it in half into two congruent pieces. So anytime I have the word midpoint, my next statement should be the names of those two pieces are congruent because of the definition of midpoint. So segment MI and segment IL are the two pieces. You also could, you could write this as segment LI, which would be more accurate for what we're doing with the triangles, because this is a rotation. So really point M is mapping onto point L and corresponds to point L. But when I do definition of midpoint, I usually write it out this way, where I have the midpoint in the middle. And I just do that automatically before I even really think about how I'm going to apply that. So it's up to you. I won't mark it wrong either way. Although the more formal version would be that you try and set up your segment pieces in the same corresponding order as the triangles are going to use them in the end. So now I've used that piece of given information. And now I want to review, do I have enough information for one of my 5 shortcuts? I have a pair of angles here that's congruent, a pair of angles here that's congruent, and a pair of segments here that's congruent. So I've got 2 pairs of angles and 1 pair of sides, which sounds like I probably have ASA or angle side. And I just need to look at my triangle and see which I'm doing. So I marked up an extra pair of angles that I didn't use. Oopsies. Don't. So I erased the one that I'm not using. So now it's a little easier to see which shortcut I'm working with. I've got this is an angle, this is an angle, and this is a side. The side is not connecting the 2 angles. It's not between them. So it's angle, angle, side. It's also acceptable to write SAA, side, angle, angle. But the key here is this is not ASA. You cannot call it ASA if you don't know that this segment is congruent to this segment. So now I can say that the 2 triangles are congruent by angle, angle, side. The only acceptable reasons to say triangle is congruent to triangle are these 5. These are the only things that you can say for this statement where you say triangle is congruent to triangle. So always be careful of that. Always make sure you have all 3 of those pieces. You can't say angle, angle, side until you have 2 pairs of angles and a pair of sides stated. So I always find it really helpful to actually mark it in my proof and mark off, okay, do I have my 3 pieces? Do I have my 3 pairs of congruent segments? Because there's a lot of statements in here because there's other statements setting up those congruent parts. But now I have actually proven the thing that I'm supposed to prove. So I can say QED, quod erat demonstrandum. It is proven. I did it. I am done.